All right. So the last session for the day, just to close out the day, is a few tips and tricks in DesignLife. My name is Bindu Akkala. I'm an application engineer with nCode. And the purpose of this session is a lot of times there may be some in here that you're familiar with or use every day. But a few times we'll get a call on the hotline saying, oh, I wish there was an easier way to do that, or oh, I didn't know that that even existed, or it'd be nice to know. It would have saved me 4 hours of work. So the purpose is just to go over some of the options or properties, if you will, most commonly used in DesignLife. So having said that, the first one is about static entity subsets. So typically, static entity subsets are used to restrict an analysis, DesignLife run, to a handful of nodes or elements. So if you have areas on your model that have static failure or infinite life, for example, so to troubleshoot, these static entity subsets are useful where you basically go into the DesignLife glyph and type in a list of nodes or elements that you want to write out the results for or stress and strain history for. So that functionality has always been there. Now, John talked about what's new in version 9, which is another way to use static entity subsets is to make a group that you want to include or exclude from the analysis. And a typical use case would be where you have a boundary condition. So if you have rigid elements on which you're applying a force, and those are attached to nodes where you have very high stress because of the application of the load, what you could do with now static entity subsets is basically create a group, and Hypermesh or any other pre and post can write that out for you. An ASCII file, with basically a file with a column of that nodes or elements that you want to exclude or include, and then point to them inside this entity source, which is basically a user set file. Okay, so rather than having to type them in manually, you can create a group, and then you can use, if you name that group something, we import it as a part of the result file. And you could use logical descriptions like not that group or include that group. Okay, so this is a new way of using static entity subsets. Okay? Another way to bring in that list of nodes or elements is using multi-column input. So if you're familiar with the GlyphWorks and DesignLife terminology, we can pipe in a glyph with an input, which is a multi-column input. So that can be in the form of a CSV file. Okay? So the summary of this point being that rather than manually typing in a list of nodes or elements, you can now import them from an ASCII file or from a CSV file. Okay? The next one is about back calculations. So rather than doing a regular fatigue calculation to calculate damage, you can also use something called a scale factor back calculation mode. And what this does is back calculate the factor that you have to apply or on the input load times the stress, which is the effective stress history, to reach a target life, say 1 million cycles or 10 million cycles. And what the scale factor did previously was had a large range of values to which it back calculated the scale factor to that target life. Now what we've done in version 9 is basically restrict that range of scale factors that it applies. So basically, the maximum is now 5, so 5 times the input load, and the minimum to be 0.2. So what we've essentially done is restrict the number of damage calculations that it needs to do to iterate on that scale factor to reach your target damage. Okay, so what this means in terms of calculation time is it speeds up the analysis because it's a far less range of scale factors that it needs to run. Okay, so the back calculation for the scale factor now with version 9 has a narrow range of values. Okay, moving on. We've added some, so a few people have asked about validation checks. So usually if you set up your analysis. You set up your load mapping, your material mapping, and just when you get to run it, it throws out an error saying, oops, you forgot to assign a material. So we've had a lot of requests to basically do some kind of upfront error checking. And this is one of the error checks that's done on the loading. So if you have more number of channels than your FE load cases, now there's a new check in the load mapping form that is basically can be set to two options. You can either ask the software to warn you, saying you have 10 FE subcases, but you have 11 channels in your time history. Or you can have it error out, which is saying there's a mismatch between the mapping. And the reason why that is important is because the order of the FE subcases get mapped one-to-one with the order of the channels that come in from the time series. And that's the default mapping. So unless you have an equal number of subcases and load channels, you might end up basically creating a wrong mapping. Okay? So the purpose of having this error check is if you have more channels than the number of loads, then you can basically throw out an error. It will always give you an error if you have more FE subcases than the number of channels. So going backwards is always going to be an error. Does that kind of make sense? Okay. In terms of material mapping, there is a validation on the material map properties, which means one of three things is to check that every group inside your material mapping has a material data set assigned. And that's basically validate before run, which means make sure and check that the material mapping, every group in the model has a material assigned. The second one being, do you want to save the material map as a part of the flow? So most of you save the flow, and you might have realized that when you save the flow and you give it to somebody else, when they open it up, the material map still has valid assignments, or it's pointing to groups that are not valid anymore or materials that are not valid anymore. Okay, so this option that says do not save the mapping, if you set save mapping to false, which is basically don't save the material map, then it basically clears the material map, and the next person who opens the flow has a fresh place to start from. Okay. The time that this can cause an issue, if you save the material map, is when you give it to somebody else, your colleague, for example, and they don't have the same paths to the database or to the materials. Okay. And the last one being the database name, and this is important for material assignments that you're bringing in, like bill of materials. For example, if you had material assignments in a CSV file and you wanted to import them from a CSV file, that's when you would need to use this database name. So we've populated it with a default database name. Okay. Moving on to the next one. So a few options on the Dutycycle load provider itself. So this one is better shown in the software. So I'm just going to. So typically, if you bring in proving ground data, you're used to making a Dutycycle up front. So a Dutycycle is nothing but a file that defines or tells DesignLife the events or that you want to add and the files that go along with the different events. So the time series channels that make up that proving ground or Dutycycle schedule. And once you make that Dutycycle flow or Dutycycle file, you import it into the analysis glyph inside the load mapping. So here's a mini trick inside a trick. If you import the DCY file or the Dutycycle file, typically you're used to doing from file, going to browse and pick the DCY file. If you do this and save the flow, then every time you reopen the flow, DesignLife is going to be looking in that same path for that DCY file. Okay? So if that DCY file changes or it doesn't exist there anymore, then it's going to give out an error. A way to get around that is to switch this configuration method to be interactive. And what that does is the glyph reads the file, reads its contents, and displays them in this editor view here. And then basically, it cuts the link to the DCY file. So if you do not have the Dutycycle file anymore, your flow still saves the configuration that you created in the DCY file. And the good thing about this is that this mapper can then be edited manually. Okay? So once I set it to interactive mode, now let's say I have a scale factor or a divider or some kind of factor that I need to apply on each of these events. For example, you might have run your FEA not with unit load, but say 1,000 Newton load. And so your stresses basically need to be divided by 1,000 before being multiplied by the time histories. So an easy way to do that across events is now there is a button on. So if I drill into the first event, and if I select all channels and go to the properties of that mapping, let me uncheck auto-configure here for a second. If I do properties, I can now put in a scale factor or divider that applies to all the channels in that event. So I'm going to go ahead and put in a value here. So when I hit OK, now I have applied basically a divider of 1,000 to all the 3 channels in my first event. Now, typically, this applies to all the events in your duty cycle. So rather than doing it manually and going into each event and editing it, if you pick any of these channels, right-click, and do duplicate setup, that basically copies that definition of a divider, scale factor, or an offset to all the other events inside your duty cycle. So I have 3 events, and so it's copied that divider of 1,000 into my second event and a third event. Okay, so this is useful when you have a list of 70 events and you have to go in and edit scale factors or offsets for each of them. Okay. All right, I'm going to switch back to the presentation. And so the presentation on your USB stick actually has the screenshots with the steps on how to set this up. So I'm just going to skip through that real quick. Okay. So the next tip or option is, you probably haven't seen this or heard of it, but it's actually buried inside Advanced Edit on the display postprocessor or the output that sends it out to display. And that's called compressed results for display. And there is a property on it called run combination. And this run combination basically applies to any runs inside your analysis glyph. So typically, any glyph that you drag and drop from scratch from the glyph palette is going to have one run, which is basically an SN or an EN or a weld or vibration, depending on the type of analysis that you do. But it is possible to make more than one run inside your glyph. And some of them, so a second run you might add to check the effect of mean stress correction, for example. So if I had Morrow versus Smith-Watson-Topper, which mean stress correction gives you the most damage or worst case damage? So in that case, if you have 2 runs inside the analysis glyph and you set your run combination to be worst, then it's going to report out the damage for the worst case run. Okay. Another option on that run combination is to do override. And so if you have 2 runs, when you set this to override, basically it takes the results from the first run, but then it doesn't save them. Those get overwritten by the results from the second run. And a typical scenario when you would do this is if you had a filter run, meaning that if you have a large FE model, you have really long time histories, a lot of events, it doesn't make sense to run fatigue calculation on the whole model over the whole entire duty cycle. So in which case you want to set up a filter run, which basically finds the list of most critical nodes or elements and then runs a full detailed fatigue calculation only on that subset of nodes or elements. So, so if you had a filter run and a detailed run that follows, then if you set your run combination to be override, then only the results from your last and final run are saved, which will be the final fatigue results to your display or to the output. Okay? And then there's another one that is far less used than the first two, which is called sum. And this is basically sum the damage from the 2 runs or 3 runs or how many ever runs you have inside your analysis glyph. And a typical use case of that is if you have a fatigue calculation followed by a creep calculation, for example. So you want your total damage is then a sum of the first run and the second run. Okay? So that's basically run combination, and it's on the compressed results for display postprocessor. All right. One got to do with the output. So output for Hypermesh specifically. So in version 9, we've added a new property to the FEOutput glyph called node on element compression. And what this means is that when you do fatigue calculations that write out node on element results, so for example, if there is a node that is shared by 4 elements, each of that node, element 1, element 2 contribution is a separate damage calculation. So you will end up with 4 answers for damage at that node that is shared by 4 elements. So for Seamwell particularly, it tends to get very complicated when we write out results to Hypermesh that have a node column and an element column. Okay, so most pre and post processors can only handle 1 column of node or element and 1 result per node or element. So what this property does is basically compress the output, and it writes out to the Hypermesh file basically a list of nodes or elements and 1 result, which is the worst case result at that location. Okay? So that's the most typical application is for Seamwell results. Okay? And then the last one, before last one. This is actually more useful for people who use ANSYS, for example. So if you have user groups that are created in ANSYS, or if you write them out from a pre and post, if a user group file exists in your current working directory, which is basically an ASCII file with a list of nodes or elements, DesignLife will automatically pick that up when you drag and drop the result file onto the FEInput glyph. Okay? If display is checked, it will automatically show that in your group listing. If display is unchecked, then it passes that user group to the analysis glyph. Okay? So it is something that is useful if you have a pre and post like Hypermesh or ANSYS that is actually making these user group ASCII files for you. Okay? Then the last one is the elimination postprocessor wizard. So John touched on this briefly in his What's New in 9 presentation. So I'm just going to show this on the same model that I had before. Just going to switch gears here for a second. And so if I had, in this particular case, I have basically a shock tower model with 3 subcases X, Y, Z stress. And inside the edit load map, I'm basically assigning 3 time history channels to those 3 subcases of stress. And by default, all glyphs are set up with 1 run, which is run the damage calculation on the whole model using the entire time histories. What's beneficial is to add basically a filter run above this damage calculation to find a list of critical nodes or elements. And the way to do that now, you would have to do this manually before version 8. Now there's a wizard to help you do that. So if you right click on analysis definition, do auto-elimination wizard, that pops up with 2 options. So you could choose between a damage filter or a stress filter. For now, I'm just going to set it to damage, do next. And then the next question it asks is, how do you want to filter your data for basically finding these critical nodes or elements? And the default is peak value with a gate. So you could set that to peak value with a gate or just a 2-point time history. So you can be as aggressive with the time histories with the filter as you want to be. Because these are not these time histories are only used as a filter. Okay? So I'm going to do that, leave it to default. And then the last question is, how do you want to keep results for this, or the number of entities for the second run? So I'm just, in this case, I'm just going to select 10% of the model, but you can choose between a % of the model, or a fixed number of calculation points, or percentage above the highest damage. So when I do finish, what that wizard does is basically build this tree structure for you with the filter run. And now when I'm just going to go ahead and run it real quick. Now you'll notice when I finish running it, it basically writes out results only for 10% of my model, or how much ever % that I specify. Okay? And you could use the wizard to build a stress-based, damage-based, and as many filter runs as you want. The idea being that you want to cut down on the final detailed damage calculation that you want to do, or the model that you want to give the software to run the final damage calculation. Okay? And the steps to set that up are also given in the screenshots to set that up are also given in the PowerPoint that you have on your stick. So that was basically my last slide. So any questions, comments?